Verifying hearing instrument fitting using multiple input levels. Individuals with sensorineural hearing loss have two distinct problems when listening to speech and other sounds: loss of audibility for soft sounds and reduced tolerance for loud sounds. Here we see an audiogram of two very different ears. The left ear has normal audibility for soft sounds, shown by the pure tone thresholds. This person also has normal tolerance for loud sound, demonstrated by very high level UCLs. This creates a normally wide dynamic range. In the right ear, however, the patient begins to lose audibility in the mid to high frequency range. This causes soft sounds to be completely inaudible for higher frequencies, and even normal conversational speech will be challenging for this person to hear. In addition, their UCLs are reduced, and therefore their tolerance for loud sounds is similarly reduced. This narrow and distorted dynamic range creates a significant challenge for hearing instrument fitting. Fortunately, advanced compression technology is implemented in most hearing aids today that will allow us to do this. However, it's critical that we do verification. We need to make sure that this UCL is never exceeded by loud inputs, and we also want to make sure that we get maximum audibility across the patient's residual dynamic range. The Medrex Avant REM and live speech mapping system makes this very easy. In NOAA, you can open this by clicking on the manufacturer's icon and then the measurement tab, and then double-clicking on Avant REM. You can also go straight to the REM icon on the NOAA toolbar. Once the software opens, click on the NOAA LSM button on the upper left corner of the screen. This will open up a floating LSM window. This is also known as the on-top mode. This window can be moved wherever you need it to be, and it can also be resized depending on whether you're looking at it or the third party and patient are. Next, we'll open up the active fitting module. In this case, it's the Phonak IPFG. Then we're going to go back to the LSM window and select Stimulus and Random Speech Noise. This is the ideal stimulus for this multi-level measurement because it's a repeatable signal. We can set the level reliably. However, this noise has the dynamic, temporal, and frequency characteristics of human speech, allowing the compression circuits to work normally. We'll set the level to 50 dB and make our soft input measurement. 50 dB is a good compromise between the actual level of soft sounds and the ambient noise that's present in most fitting offices. With the level set to 50 dB, we'll click on the green button to start the recording. After 5 to 10 seconds, you can stop the recording and note that the blue line indicates that the output of the hearing aid for that level is audible across the patient's residual hearing range. Next, we'll move the slider to the 65 dB level. This is consistent with the level of average conversational speech at about 1 meter. Click on the green Start button and make another measurement. After stopping the measurement, this curve should lie within the white modified speech spectrum as shown here in green. Finally, move the slider to 85 dB and begin a third measurement. The goal here is that no part of this curve will touch or exceed the UCL. Seen here in light green, we have achieved this goal. So in summary, we have audibility of soft sounds, medium sounds are comfortable, and loud sounds are tolerable. We have achieved the ACT or ACT principle, and this fitting is essentially bulletproof. If you perform this process with each and every one of your initial fittings in a very short amount of time, you'll be able to ensure that all of your patients perceive benefit but receive no pain or discomfort while wearing their hearing aids.